In this video, we're going to be covering another interview question here. And the question goes like this, that let's say there is a classroom and we need to, and there are going to be some companies coming in for some presentations. So we're going to be given, I'm sorry about that. We're going to be given the number of companies. Let's say if there are 5, then with that we're going to be given so these are the companies. One company shows up at time 1 and it stays for 2 hours. Six, seven, eight, 6, 7, and 8. So the first, the companies where the arrival time of the companies is gonna be like this: 1, 3, 3, 5, 7, and the duration for which for how long they're gonna be staying here is gonna be given in another array. That would be 2, 2, 1, 2, and 1. So the first company is coming at time 1 and stays for time 2, what's gonna happen is gonna end at 3. The second company is gonna show up at 3 and it is gonna stay for another time 2. Could be hours, could be minutes, whatever. Third company is gonna show up at 3 too, and the duration is 1. Then the fourth company is showing up at 5 and it is staying for 2 hours, and the last company is showing at 7 and it is staying for 1. So there is a twist in the question. They have given you the arrival times and the duration of them. What they could have done is, instead of making it hard, is that they just tell what is the ending time. They didn't do that. So in other words, one thing I can look in this question is that we need to create an ending time too. So 1 plus 2 is gonna be 3. 3 plus 2 is gonna be 5. 3 plus 1 is gonna be 4. 5 plus 2 is gonna be 7. 7 plus 1 is gonna be 8. Now this information is not relevant anymore, and we have an arrival time and an ending time, and we can see that the company 1 is gonna start from here and stay up to here. Over here we have an overlap. This is the only place in this example where we have an overlap, so we can actually select this one, right? And then the rest of them are gonna, so over here we're gonna be choosing one company here, one here, one here, and one here. So the total which we're gonna be returning back, that the total number of events we can actually organize are 4. Okay, in terms of the pseudocode, it is very simple. Like what the strategy is gonna be that we're gonna be creating an event, right? Taking this information and this information, we're gonna be creating an event element, which will have, what it's gonna have is like, okay, what we're gonna have is like event is gonna have a start and it's gonna have an end. Okay, So we're gonna have a start and an end, and that's it. So every event is gonna have a start and an end. So in our example, we're gonna have events like 1 and 3, 3 and 5, 3 and 4, 5 and 7, and 7 and 8. That being said, once we have all these 5 events, the next thing we're gonna do is that we're gonna be sorting them, right? The sort, what we're gonna be doing is we're gonna be looking for is that whoever has a bigger number, that's gonna go. So basically, we're gonna be sorting them in ascending order, right? Whoever has a this ending. So these numbers are gonna be sorted like this: 1. So comparing them, all of them, the one which is ending at the beginning is 3, right? Number 1, number 2, number 3, number 4, and number 5. So our sorted list is gonna be 1, 3, 3, 4, 3, 5, 5, 7, and 7, 8. Again, we sorted by the end. So they are in the sorting order by the end. After that, we're just gonna take 1 and we're gonna say that this starting point, is it less than the ending point of over here? It is not, so we're gonna increment the counter. So our count is gonna get incremented. Again, we're gonna take our this next element and we're gonna say that is this one, is the next starting point is less than the ending one, and we're gonna say no. Yes, it is, so we don't want to count it. And then the next one is like, if this 5 is less than this 5, it is not less, so we're going to increment the counter. If this starting point is less than the ending point, we're going to say that okay, it is not less than that, so we're going to increment the counter. And in the end, we're going to be returning the count. Let's write the code here. Okay, how should I try that? Let's do this one. Again, we're gonna start with the class event, which is an integer start, and we're doing it in Java, and end, and also a constructor saying that if you get int s and int e, just assign the start equals to s and an end equals to e. Okay, once we have that class, we're gonna have our class result. Okay, then our function is basically gonna be, without going into the public or private things, it's just returning an int. Let's call it maximum events we can organize, right? And what it is taking is a list of lists of integers. Again, two things. One is the arrival and list of integer. The other one is the duration. Okay, now we're gonna say that the int n is equal to the arrival dot size. Once we have that, we're gonna be creating a list of event classes, which is equal to new list array list. Sure. Okay, that being said, once we have that, we're gonna fill it up. So int I equals to 0, I is less than n, I plus plus, events dot add. What we are adding is a new event every single time. The first thing is gonna be the arrival dot get that ith element, right? So this is the arrival, the starting point. Now for the ending one, we're gonna say that the arrival dot get of I plus the duration dot get of I. Okay, that would be it for filling things up. Now we're gonna sort them. Collections dot sort. We're giving it events. Made a mistake here. Events, and then the lambda is a and b, and we're just gonna compare end minus the start. Oh, sorry, and a dot end minus b dot n. Okay. So once we are done with that, we're gonna initiate our counter by saying that int counter equals to 1. Then also you can, to make things easier, last finish equals to event dot get. And remember why we made a counter equals to 1 is because in that question we have been given the assurance that there's going to be at least one event which is happening, and you will see when we're going to be running the loop, we're going to be starting the I from 1. So we will not we are guaranteed that there's going to be at least one event happening. Okay, so that's why we already know that the events dot get 0 is gonna exist, and we said that the last finish is this one. Now when we are starting the loop, we're gonna say that the int I equals to 1, I is less than n, I plus plus. Okay, if the event dot get of I dot start is greater than equal to events, oh sorry, last finish, right? If that is the case, if it is greater than that, then sorry, if the start is greater than equal to this one, the previously finished one, then it means that we can organize the event. So the counter is gonna get incremented, and the last finish is gonna get updated. Events dot get of I dot n. The last thing I was wondering is that let's say if when we are comparing it, if let's say in this case it was not big, right? Yeah, so what we are doing is, like, let's say I cannot see the marker, right? So over here, where is it? So just let me, so in the second example over here, what is gonna happen? I can do that. So in this example over here, when I said that this is the last finish, and the condition wasn't met, I didn't update it. I didn't make it 5, and there is no need for that. So if that is the case, we are not gonna update it. So that's why there is no else condition in there. So we can keep the last finish as it is from the previous one if the condition is not met. And then we're gonna just be returning the counter. That would be it. In terms of the complexity here, I'm gonna be talking about that. Let's just go back to the pencil. Okay, the complexity. So let's look at our code here. So talking about the space complexity here, we are having any we are having we are going to be taking the some space here, right? And that would be n. So the space complexity is going to be O of n. In terms of the time complexity, this is the space. In terms of the time complexity, the main thing we are doing, this is just the n, and there are two loops, both of them are n, but this is collection is sorting them, right? So we have creating the events. So basically it is n log n, and whenever we are sorting them, uh, whenever we are sorting the events, that's gonna be the n log n. Yeah, because we are sorting the events, so that's gonna be the time complexity is gonna be n log of n. This is the thing which is taking the most of the time. Yeah, that's it for this video. Thanks for watching.